Anyway, so here we go. I apologize that Fridays wasn't posted. I recorded, I did everything I needed to, but then I went home and I forgot the videos are on the computer. Okay, so more on flowcharts. If you would find some white space, not on the bottom of page number 3, maybe there's some on the front cover. What do we got here? Oh, there's not a lot of white space, but it's good enough. All right, I want you to draw this flow chart. And if you don't know how, it's okay. But what I want to do is I want to use a flow chart or teach a flow chart using the example of the 3 major universities in Utah. There's more, I know, but here we go. You have Utah, BYU, and Utah State. And I want to use a flow chart to separate them into their 3 separate groups based on a property or 2 of BYU, Utah State, and Utah. So take 1 minute. And if you don't know what to do, at least draw the shapes, like draw this structure. We're going to do this a couple times. Now, you can't just write like BYU, yes, no. Utah, yes, no. That doesn't count. It needs to be a property or characteristic of BYU, Utah, and Utah State. The difference between Utah and Utah State, the University of Utah is in Salt Lake City, has about 40,000 people. Utah State is in Logan and probably has like 28,000 people. Now those stats are 25 years old, so I don't know anymore, but they are 2 different universities. All right. So we're trying to learn about flowcharts. Flowcharts, we ask questions to break things into groups. All right, talk to your partner real fast, see if you have ideas. I'm seeing a whole lot of nothing, which indicates confusion or laziness, 50-50. Perfect. Nice job. Okay, so here we go. Right up here in front, you all right if I use yours? All right, she said, is it a state school? And then she had, yes, I'm going to put it different because I have my boxes on this side, but it's the same as yours. She had yes and no. So which one of these 3 schools is not owned by the state of Utah? BYU. All right, I won't offend anyone by writing that in red. All right, so BYU is not a state-sponsored school. It's sponsored by a church. So we now have 2 schools over here. I don't write them down, but I have the 2 schools left are the University of Utah and Utah State University. All right, what is a fairly easy question to ask here? Are they red? And then my yes would be Utah. And my no would be Utah State. Good job, Ariana. Okay, so what I did, I used 2 of their characteristics. One, the type of school, state versus private. Nice hoodie, Shelby. I like that. It's okay. It's okay. And then the second characteristics, we use the color of their mascots, basically. So we have red versus blue. This would be a no right here. Okay, so this is a basic flow chart. We end up with 3 groups. When I ever ask the number of groups, like I want you to do, it means the bottom, not 1, 2, 3, 4, 5. It means I have 1, 2, 3 ending boxes. You okay with that? All right, we're going to do another one. You're going to use a flow chart to separate Burt, Miller, and Davidson based on some characteristics. You can get creative, but don't get hurtful. Burt knows he's ugly, so we don't need to tell him. So you can put this anywhere you want. Yes. I should I mute my microphone? Okay. Oh yeah. Mm-hmm. I win. Miller's Across the Hall. He teaches biology, AP biology, and intro to health science. He coaches cross country. He went to high school in Colorado, as he says, which is way gross, but he's from there. So I guess maybe I say it wrong. I almost refuse to admit. No, Colorado. It's not Colorado. No, thank you. That's wrong. Even though he lived there for 30 years, I think I would know. My dad lives there. Bert is a driver's ed teacher. I am a driver's ed teacher. Mr. Miller is not a driver's ed teacher. Bert and Miller are ugly. I am good looking. I am funny. They are lame. There's all sorts of ways to separate us. Now this chart, a lot of you didn't even try the Utah one, but you dang well better try this one. I do teach driver's ed. When? There's 5 of us. I know, crazy, huh? Uh-oh. Driver's ed, no. Miller, yes. You have like the easiest question ever. You could say, are we related? Like you're the only one that can get away with that one. How we doing? There's not one single way to separate me and Peter Burt. Thank you. Well, after this year, that won't help. Oh wait, no, I did. That's my favorite one so far. I should post these. Let's see what we got here. Got you. You can call them bald. All right, so here we go. I am a coach. Fish? Oh, in their room. I'm like, I fish. What does that say? That says Utah born. Oh, Utah born. Okay, I got you. All right, let's see here. Likes good music. I like that. I am the only one, Adam, that teaches the class called chemistry. Okay, here we go. So as I walked around, most people said driver's ed. And then that would mean this side is the no, correct? So that would be Miller. You could ask this same question right here by saying, is he sane? And that would be Miller. And I would go this way. All right, yes. So now Peter, Burt, and I are over here, correct? So then you had to ask a defining question. And I like Sydney's, I'm going to write it just this way. Bald. Yes, he's bald enough. And Davidson. Now I got a question. How many of you have this exact same flow chart? Nobody. Does that mean all of you are wrong? No. Flowcharts are like fingerprints. They can all be different. They should probably have some similarities, but the only way to go wrong in a flowchart are these two things. And that would be if you had the same thing in more than one ending box. That's a no-go. So you wouldn't say Miller is not bald, right? Miller's not bald, but why is he not in this box? Tell your partner. Okay, because he was already removed, right? He was not on the list to ask questions about anymore. So one way to go wrong is if you have the same thing at the end in two different spots. And then the other way to go wrong, and it's not a big deal, it's just a waste of your time, is to ask a question that's all yeses or all nos. So you could ask, are they humans? Well, okay, but that doesn't separate. They are, I believe. Bert might be a robot, but I doubt it. All right, so don't ask a question that only has one answer. That's the way to do it, or way not to do it. Okay, now let's look at the lab and let's see if that helps refine the flow charts you were supposed to make. So it wasn't really a lab, it was just that activity. You should have your 15 things, and then you need to get 5 ending boxes. That's all I'm looking for. So if I was doing it on this chart, let me do it on this one. This would give me 1, 2, 3. So I better ask at least one here, and then I have 1, 2, 3, 4. So I guess you have to have 6 if you're going to have 5. It looks something like that. You with me? So look at those properties, like, is it solid? Is it a liquid? Is it white? Is it gray? Is it yellow? Is it crumbly? Is it fine? What other, is it like thick versus not thick? Stuff like that. Those are the type of questions we're looking for. So will you please take the next 5 minutes and come up with a decent flow chart from, see if she'll let you copy that from that data. If you've already done the flow chart, look to see if it's a decent flow chart. Here, I'll take a picture of hers and then you can just look at this. You two stayed partners, apparently. I hope you get along. Talk about, let's see, white. Okay, so right up here I have white. Did anyone else choose that as their starting substance, their starting question? Raise your hands. Oh no. Does that mean she's wrong? No, it doesn't mean she's wrong. Then she had all sorts of stuff, and I'm just going to come down here eventually and say 11 and 13. Okay, everyone look. How many of you had 11 and 13 in the same box? Raise your hands. Okay, so even though started with different questions, we still have most people that have 11 and 13 in the same box, correct? The flow chart usually, as long as you ask like not crazy questions, you'll end up with the same things together because they have similar properties. All right, this box 11 and 13 is extremely critical. Do you know why? No, they are clear liquids. 11 and 13. You have no idea. What have I done? 11 and 13. What? It's my birthday, kids. Good heavens. Do you not pay attention to anything in this course? November 13th is my birthday. Is it in your phones yet? Yeah, it's obviously not in your minds yet, though. So everyone circle that box, and you need to put Davidson's birthday is a clear, colorless liquid. Are we clear? Okay, that's all I want. Well, actually, I want it to be yellow, have a little bit of bubbles in it, some caffeine. Yeah, you guys got them right after. Anyway, any questions on why that box is important? We are roughly, what, 10 days away from October 1st. October 1st is the beginning of my birthday quarter. I am fine if you start bringing me Mountain Dew on October 1st. Anytime between October 1st and January 1st is pretty much my birthday. Are we clear? 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 Garrick? Now, no toothpaste Oreo cookies like your sister did to me. That was hurtful. All right, that wasn't on my birthday. That was April Fool's. But how dare I trusted her? Has anyone ever had a toothpaste Oreo? They're disgusting. It's just straight up terrible. Colgate and chocolate wafers. Okay, now I am joking about my birthday, whatever, but how many are okay doing a basic flow chart? Raise your hands if you are. Okay, we're gonna have a super easy one. Turn to your homework. Now, this homework, there's a lot of them, but it actually goes really fast. Would you, at the top of page 13, where it says elemental tail practice, will you write the word in all caps, homework? Now, we'll do a ton of it together, I promise you. More than last lab book. But just in case there's any confusion, that's where your homework starts. Okay, so we're going to end flowchart discussion by looking at 28. It says, using physical characteristics, make a flow diagram or flow chart that someone could use to separate cats, rats, and dogs. Are you rolling your eyes at me? Okay, sorry. Cats, rats, and dogs. That is your goal. Break them up into 3 separate things based on their physical properties. Ready, set, go. Cats, rats, dogs. So number 28, cats. Oh, we got someone doing something. Good pets, huh? Nice. This looks very warm. This is what I do every time. And then people are like, I'm confused. I'm like, I think it's kind of easy, but okay. Oh, you probably don't need this anymore, right? Okay. You're reading all my group me messages. They are fascinating. I get like 100 a day. Nice, that's relative, but it's okay. It's your flow chart. What do we got here?
So it says felines at the top. So
Okay.
there's cats, and then no, and then it says snake food. Yes.
Okay. Okay. All right, take about 10 more seconds and then we will wrap this up. There's a reason why we're going over flow charts. It helps us to classify groups of information, and we're going to do that quite a bit. All right, so your flow chart may look completely different than mine. In my opinion, there's only one of them that bark. And to me, I'd put a yes and I'd put a dog right here. Now, how many use bark in there? 1. Does that mean that we're the geniuses? No, I mean, yeah, we are. But also, you can ask 100 things. All right, as I walked around, most people said something about being in a pet. No. So now I have a cat and I have a rat, and I'm going to say, does it meow? Not positive. I think that's how you spell meow. So yes would be a cat, and this would be a rat. And I think we'd be done with this. Okay, so ask yes or no questions. Only write the things at the end if you're not going to ask another question. Like I didn't write in this box cat and rat. I don't write them till the end when I'm done asking questions. Okay, that's flowcharts. We're going to, review them and work with them all trimester, honestly. Okay, now we have some notes called concept development. Page number 4, 3, 2, 1, I don't know, probably 4. Ooh, right there. What is that? 5. Oh yeah, we have the matter lab. Page 4 is the matter lab. We'll work on that tomorrow. So we got to make sure my TA sets that up. Okay, so concept development, almost all of your matching terms come from page number 5 on this test. All right, and some of them, like you've learned for decades. I hope that you already know matter is anything that occupies space and has mass. So anyway, this is the main page where you get your matching terms. All right, so fancy slide. Made this slide myself. Most slides I just imported, someone else made them, but whatever. It's really cheesy and whatever. But anyway, matter, anything that occupies, that takes up space and has mass. I guess I said it backwards earlier. All right, 2 new words possibly to you. One is heterogeneous, and that means not uniform in composition. So this is a piece of granite. Granite is considered a heterogeneous rock because it is not uniform in composition. We have some pure granite, we have some blue schist, we have some onyx, we have multiple types of things, all just gobbled up in this granite. So when you look at something, if it doesn't look all the same, we are going to define it as heterogeneous. So if you look at trail mix and it's got the peanuts, it's got the M&Ms, it's got the raisins if you bought the gross kind, it has the other stuff, right? You can see different types. So you would say that trail mix is heterogeneous. We okay with that? All right, versus the other one is called homogeneous, and that would be like looking at milk. If you look at milk and you see different parts, then don't drink it. Like that's first rule of not throwing up survival. Okay, milk is actually called homogenized, meaning it is all one substance. So when we talk about heterogeneous and homogeneous, we mean how your eyes actually interpret it. We don't mean on a molecular scale that, hey, what did I say, Siri? EL5, how do I know if a gene is heterogeneous or homogeneous? Thank you. Blue eyes are recessive, meaning you need 2 blue eye genes to get, what the? Thank you, Siri. All right, that was odd. Okay, anyway, so it's how we look at it and see it. If we look at this tabletop, it's pretty much just black. I would say it's homogeneous. If you look at how this is painted, technically, you see there's more than one substance. It's just fake paint. But anyway, heterogeneous, homogeneous. All right, to test your ability to think these through, I would like you to tell your partners, you guys already in this group, you are talking a little better than your last group. So here we go. Tell your lab partner how the people in this room are homogeneous. And then I want your other partner to tell you how the people in here are heterogeneous. Ready, set, go. if you're in the middle and you're like, what do I do? There's three of us. Well, say another thing. I don't know. Gabe, can I sit here? Oh, that's perfect timing. There you go. You're welcome. Okay, so Gabe, how are we all the same?
We're all
All right, we're all students. I am. I'm always learning. Nice job. Okay. I don't know, Camille, how are we all the same? We are all people. Anyone have something besides that? How we're all the same? We're all wearing clothes. That's whatever that says wearing. I don't know how to spell clothes either. T-H-E-S, is that how you spell it? Okay. This will happen a lot. If you get to the edge of this and you're writing, it just like shoots once in a while. Okay, so those are ways that we're all similar. All right. How are we different, Haney? Yeah. All right, we all have different hair, right? Different lengths, different styles, different ways of doing it, whatever. Okay, our hair's different. How else are we all different? Anyone else just want to shout out? Wells? Okay, Coley is rotund.
not wrong. You even spelled it right. That's impressive.
I did? What? I doubt it. I got Cummins right here. Yeah, that's all that matters. Just when in doubt, scribble it out. All right, so we got hair, our weight, our height, our eye color, our attitudes, our whatever. There's a lot of ways we're different. And there's also a lot of ways we're the same. We're all students. We all live in we all go to Box Elder High, because you know what I mean. We're all people. We all are wearing clothes. We're all going to go to Beefcake tonight and cheer on the announcer. And all the stuff. We are similar. Okay, these prefixes right here, homo means same, and hetero means different. Okay, and we won't go into whatever you're thinking about, but it makes sense, does it not? Okay, moving on. Here is some heterogeneous. There's granite again. Human blood, I don't like this slide, never mind, because it's how you look at it from your eye, so forget it. And someone will pass out by me saying that word. Okay, now we're going to talk about elements, compounds, and mixtures. The definition of an element, you must know, that's a matching term. It's the simplest form of matter that cannot, oh, this is annoying, be further decomposed by ordinary chemical means. I bought a new projector this year, which has a different screen. What am I looking for? Ratio. So tons of my slides are off. Oh well. Okay, so an element cannot be decomposed. It's the simplest form, cannot be decomposed. Now we can have a nuclear bomb, but we're not going to do that in this class. I'd get fired. So, well, I'd be dead. So it'd be fine. But anyway, we are talking about chemical reactions. An element cannot be broken down. All right, a compound is matter that can be decomposed into two or more simpler substances by ordinary chemical means. So I can take water. So I have H2O, and I can decompose it into H2 gas and O2 gas. So water is a compound because it can be broken down into two elements. And these elements, they stick together. They cannot be broken down by ordinary chemical means. Okay, this is probably sugar. It is C6H12O6. Has anyone ever burned any sugar? Like, it's gross. It turns black, right? And that is because you get carbon and you get water out. So it will steam and then it will leave something black. So like when you put barbecue sauce on something, then you barbecue it and you come back and it has all that black stuff. That's the sugar breaking down and leaving carbon. The water was driven off as part of the smoke. Most of the smoke you see coming out of your grill is just water vapor. Anyway, so these things are things that can be broken down. So they would be called compounds. All right, mixture. That's matter composed of two or more physically blended substances. In a mixture, each substance retains its own properties. All right, so we have these M&Ms. And M&Ms, this is maybe the bad example because they all taste the same no matter the color. But when these are mixed together, the green ones are still green, the brown ones are still brown, and the blue ones are still blue, right? They have their own properties. Maybe trail mix again. So when you mix trail mix, the raisins don't magically become good tasting, right? They still taste like raisins. The peanuts taste like peanuts. They have their own physical properties that they retain in a mixture. That's the key to a mixture. In a compound, things change properties, but in a mixture, they do not. All right. And trail mix is physically blended. It wouldn't take super long to separate it all and throw the raisins away and eat the rest, right? If you're a raisin lover, I apologize if I'm hurting your feelings. But the population of raisins lovers has decreased over time. So I doubt I offended too many of you. All right, so here's just whatever. We have atoms of an element, molecules of an element. So it's still the same element because they're the same substance, like they're just two yellow things stuck together. This would be molecules of a compound. It's a compound because now we have two different types of atoms, the brown one and the blue ones. And then over here, we would have a mixture of two elements and a compound. So we have the molecule of elements here, that'd be like oxygen. And then we have the monatomic atoms right here, right? And that'd be like, I don't know, whatever you want, just pieces of iron. And then we have like ammonia right here, these things right here. They have an N and three H's. So anyway, okay. Physical changes alter a substance without changing its composition or properties. I made that slide myself, kids. So as you look at this slide, I want you to think of one example of a physical change. All right, tell your partner an example of a physical change. Tearing paper. How'd you know? Tearing paper. If I tear this in half, sorry, Aubrey, we're still friends, right? Here, I'll just tear this side. Is this still paper? Is that still paper? Can I still write on it? Is it still white? Is it still foldable? Yeah, everything about the paper is the same, except for I just made two pieces of it instead of one. So the paper has not really changed. Now, if I were to light this piece of paper on fire, would I still be able to do all those things? No, because that would be a chemical change. All right, so that's next. Here we go. Chemical changes create new substances with new properties. So instead of a piece of paper, we would have ashes, we got heat, light, smoke, everything that came out. There was definitely a change in properties. Okay. So right under here, we have 6 examples, and it's asking you to classify each of the following as a physical or a chemical change. Do you two know each other? No, you should talk to each other. Garrett, Sydney, Garrett. All right. There's no other person on that row. So you might have to work with each other a lot. Okay, so looking at these 6, put a P if you think it's a physical, a C if you think it is a chemical change, and then tell your partner, and we'll look at it together here in a second. But try first. Did you tell your partner, Grellis? I feel like there was no discussion at all because you were too busy texting your boyfriends. Weird. Did you guys talk? Thanks for being here every day.
I know, I've been so good.
I am extremely impressed.
And it's first hour.
You're
But
doing
that
well.
almost makes it easier.
Oh, really? Okay.
So like, okay, wasn't something like if it wasn't reversible, like chemical,
What's that?
it's not reversible.
Then it's chemical. Then it's physical. You could tape it back together. Yeah. All right, let's go 30 more seconds. Or be silent. That's fine too. So we're done. Here we go. So boiling water. So when you boil water, it goes from a liquid to a gas. Does anything else change about it though? No. So we would say this is a physical process because it's still water. It's just hot water. It's steam, right? But it is still H2O. All right, burning coal. I'm probably the only person in this room that grew up with a coal burning stove to heat their house. I had to shovel it every morning. I know you're like, is he 200 years old? I actually am. No, this house was really old in Vernal. All right, I assure you, when you burn coal, it gives off heat, it gives off light, and it leaves something that we call clinker, which is just a gross substance that's useless. It's mostly iron. So when you burn coal, there is a huge change. So we would say this is a chemical process. Anytime you see burning, don't even read the next word. It's going to be chemical. Burning is chemical. All right, cutting paper. If you got this one wrong, you're literally paying no attention at all. That is a physical process. That was our example we used to learn about physical processes. All right, this one people get wrong all the time. And it's okay, this is the first time. By the end of the year though, then I get ornery. So here we go. Sugar dissolving in water. Raise your hands if you think it's physical, and don't be scared here. Physical, raise your hands. The whole back row, and 3 more of you. Okay, raise your hands if you think it's chemical then. All right, the majority of you think it's chemical, but it is a physical process. Now, back row, let's hear why. Pick a representative and have one of them. Okay, all right. You were there. It's not changing the... Perfect. It's not changing the sugar molecule. It's just spread out. So if I were to draw something dissolving, oh, I already have. We're taking a chunk of sugar that we can see, and we put it into water, and then it breaks into smaller particles that I cannot see. But are they still there? Yeah. Here's your experiment tonight to prove it. Take your soda pop and pour it all over your kitchen floor, and then let it sit till tomorrow morning and walk through it. What's going to happen? It's going to be really sticky after you get beat, right? But it's going to be super sticky because what was in that drink, even though you couldn't see it? Sugar. We evaporate the water, we're left with sugar, food coloring, and don't really do that. I mean, that'd be the stupidest thing ever. All right, so don't really. But dissolving is a physical process. All right, melting butter. So the question, is it still butter? Yeah, it's just liquid butter. So phase change is always a physical process. And then finally, Alka-Seltzer tablets in water. Does anyone even know what that is anymore? All right, good. It's that white tablet you drop in and it goes ham, right? You're like, woo. ham means crazy, loco. Okay. Sorry. There's probably kids in here that don't know what I mean when I say it goes ham. But it just goes from this solid white thing, you put it in water, and all of a sudden it's just effervescing. It's bubbling, right? So is it dissolving? No. There's a huge difference here. This one, when you add it, it causes a chemical reaction to happen. It gives off bubbles. All right. And let me demonstrate if I know where my key is. Oh no, not that pocket, not that pocket, not that pocket. I let my keys, oh, it is on there still. Never mind, I have it. I will get an Alka-Seltzer tablet. I will get it while you write the word matter in this top box. All right. How many of you can picture in your mind what it looks like when you pour sugar into water? We've made lemonade before. Uh-oh, I got no time. Does it look like that? Does sugar do that when you add it to water? Definitely not, right? So how come I think we get out at 50 every day? So you can see the bubbles right there. Those bubbles. All right. I can't wait to see all of you tonight at Beefcake. Watch Maddie's team bring home the dub. Good to see you, my metalhead. All right. Hopefully that went well.